Man, go on. I wish you were as funny as you think you were.
I know I'm funny, Mr. Kenny.
I didn't say you weren't funny. I said I wish you were as funny as you think you are. All right. So right here, I need to talk about this. So this is one of the prime questions that y'all struggled with on your test the other day. And so we need to talk about this. I created this question to assess how well we understood. Hey, which representation are we looking at here? That's not the question I asked. We need to be careful with our language. Which representation is this?
Algebraic.
Algebraic, right? How do we know this is algebraic, Preston?
Because it's an equation.
It's an equation, right?
Yes.
As we're not hitting people with our key lanyards. Thank you. So, we need to recognize that this is an equation, so it's algebraic. First off, a whole lot of us skip talking about the mathematical representation when that was a part of this question.
Yes.
Right? What's that temperature at? It's at 70. Okay. I'm not turning it up anymore from there. But we're talking about, no, I said just leave it where it is.
People don't see 7.
No. It's going to be too hot.
Guys,
It's going to get hot.
hey,
60 something.
focusing on this mathematics, focusing here, right here, eyes and ears. Excuse me. So we need to recognize it's algebraic, and notice we have answers all over the board on what type of function it is. Now, what is the most common response for this type of function? It's exponential. Now, have I ever given you, if this is exponential, have I ever given you an exponential like this?
No, not at all.
So that can freak some of us out. But, and I need Cameron, I need your eyes on this, what is telling so many of us, telling 18 out of 25 of us, 24 of us, that this is exponential?
The exponent.
What about that exponent?
It's an X.
In the exponent.
Okay, use another word. There we go. Say it again. The variable. Guys, as soon as I see a variable in that exponent, it doesn't matter how complicated it gets, guess what type of function that's going to be? Exponential. Now, we can add some more stuff in here, but I do want to point out, I know this was not on a calculator portion of the test, but watch what happens here. Just to confirm this, all right, I'm going to type in this equation. What was it? 3 times 2 raised to the x minus 5 plus 3. Oops, be careful with that. Plus 3. I want you to notice, does it have that flattening out and then curving exponential curve like that?
Yes.
It looks different because it's not at the x-axis, but that's still very much an exponential function.
Yes.
We haven't studied our transformations very much, but all it is, notice, usually it's at the x-axis. How far has it been translated up?
Like 5. Hold on, 3.
1, 2, 3. Because it's plus 3 at the end. That was it. It's still exponential as can be, though. Okay, so we got to remember when we look at these algebraic equations, what are the key details of this function? Well, an exponential has a variable in the exponent. Notice the second most common response here was quadratic. Why is it not quadratic? What do we need to see in quadratic? We would need a square, right? We don't have a square. Now, I need y'all to be careful about this because this was a super common response as well. Hey guys, if we say standard form, vertex form, factored form, what type of function am I referring to?
Quadratic.
So should we have put anything about standard vertex or factored form?
Pretty sure we should.
Pretty sure we should not. Hey guys, I need to make this more clear. When we talk about those different functions and the different equations, really when we say slope-intercept, we should say the slope-intercept form of a line or a linear function. The standard form of a quadratic, because there's actually a standard form of linear as well. There's a standard and then vertex form of a quadratic, factored form of a quadratic. Because the whole thing there is those forms tell us different features of the quadratic. And so we need to keep those things in mind. So this is what type of function? Exponential. How do we know it's exponential? Variable of the exponent. Then, from there, we need to recognize it's not any of those forms. Now, one of the reasons why I'm going over this is a whole lot of y'all need to be able to show me more proficiency than we did on that test. I finished scoring them. I have not put the grades in the grade book or anything like that, but I'm going to have to. Now, what I'm going to do for you, and I need y'all to hear me clearly on this, because this is grace on you for not doing what we needed to do to prepare, is I'm going to give y'all after lunch about 20 minutes individually to look at your test and to figure out what you need to study more to be prepared for 30 minutes of working on that test on Monday.
Right.
So on Monday, you're going to have how much more time for your test? 30 more minutes. I'm going to give you 15 to 20 minutes to look over your test, and I'm not going to let you write down equations or actual problems, but I will let you look at your proficiency scale at the same time and circle on the proficiency scale the concepts you need to study.
Right.
Does that make sense?
Right.
Because I want you to study and I want you to master these ideas so that you can be successful long term. I don't care when you learn it, but I do care that you learn it. And at this point, I do care that we start to put in a little bit more effort in class and outside of class. I'm giving you extra support here. Please don't waste this. Is that clear?
Clear.
Okay. Now let's look at the second one, because the second one is probably the most common one that... Oh.
Whoa, what is that?
Did no one respond?
I'm pretty sure I did.
I'm sure I did.
I did.
Okay. Can y'all go back in, make sure you actually have responded?
What are you doing?
Because I have not stopped the poll yet.
Let me go back.
Oh, Lord.
So if you go to the home, it should give you an option to go to the quick poll.
I'm getting old.
Make sure you have put an answer in there.
Yeah, I did.
How you doing?
Okay, submit it for me.
Just,
The way you submit it is if you click in the top left, there's a little like box looking thing, and then hit submit. If it doesn't work from there, we'll just...
Kenny, how do I go back to
I just
the
submitted.
bell ring?
Cam,
Alright, submit my.
Cam, give me that one right there in front of you. Get out.
That's so weird.
Oh yeah, mine's on my screen. I already submitted.
Huh.
I've been submitting.
Alright,
Not that one.
we don't have a way to see it then, so let's...
Right.
I wonder if I stop the poll, if it'll show up.
You submitted mine, didn't you?
There's those answers. There are no answers.
I just submitted mine.
I said mine wrong.
I've been submitting mine. I can go back.
Alright, I don't know. So, I don't know what y'all responded, but let's look at this again. What was the equation? 3 times x minus 4 plus 5? So what are y'all thinking?
Vertex form.
No, vertex form?
Yeah, vertex form
Yeah.
and.
That's it, really. To me.
Let's carry that statement out. Vertex form of a what?
a line.
I need y'all to look at that again.
Equation.
Vertex form of a line does not exist.
Equation.
If you're going to say vertex form, hey guys listen, we got to recognize this. If you're going to say vertex form, it's vertex form of a what?
Equation.
Quadratic.
I didn't say that.
Look at that equation again.
That has no square.
Say that again, Dewan.
No square.
Guys, there's no square there. Is that a quadratic?
Yes. Oh no.
No, only if it was x squared.
Guys, I need y'all to hear this one more time. There is no square there, so it is not a... It's not standard, but I will say this. You know how in a quadratic, what would my vertex have been? If this was quadratic, what would my vertex be? 4, 5. And so this is actually known as the point slope form of the line. And so what point would this function have?
4, 5.
And then it would have a slope of 3. So this was to assess your recognition of, hey, if it's quadratic, what does it have to have? A what? A square. This doesn't have a square, so is it quadratic?
No.
No. I need us to recognize that if it doesn't have a square, it is not quadratic. Notice it does still have this point, but it's not a vertex, because what's the only type of function that has a vertex? A quadratic is the only function that has a vertex. So we're not going to call this a vertex form. Remember, if it's not quadratic, are we going to call it standard form of a quadratic?
No.
Are we going to call it factored form of a quadratic?
No.
Are we going to call it vertex form of a quadratic?
No.
Okay. Are we comfortable with this idea?
Yes.
What questions do you have?
Mm-hmm.
Amaya? We good? Jamie? John?
Comfortable with this concept.
Okay. Are we comfortable with this idea? What questions do you have? Amaya? We good? Jamie? John?
Comfortable with this concept.
Are we good?
Comfortable with this concept.
Comfy, Caden? Okay. Demai, you got a question? You good? Okay. Guys, I need us to understand this. You're gonna have extra time for these kinds of questions. By the way, guys, we need to justify our answers better. If you put an answer down, that's a claim.
Yes.
I need evidence for that claim. Keep that in mind.
I
All
thought
right.
it was only with car insurance.
You know, I've been teaching you, well, I won't say that. I've been teaching all of us for 8 weeks. We know if we have a claim, we need evidence for that claim. Okay. So, let's talk about this really quickly. What type of function then are we dealing with g of x?
Exponential.
Exponential, we all comfy with that idea?
Oh, wait,
Amaya, why do we have an exponential with this g of x?
Uh-oh.
I don't know.
Hold on, we just talked about this.
Can I
Did
say
I do it?
Can I say it?
No. Kamaya,
Don't ask
help
me.
Amaya
Don't
out.
ask me.
I know
Don't
it.
ask me.
Girl, we just talked about this.
Alright, tell some bless my drama.
I'll say
Look, pause.
Bro,
Pause.
I got it, bro. I
Pause.
got it. Let me do this.
Wait, Wanda.
Hold up. I know you got it.
Okay.
I need more of us to make sure we got it. So hold on one second. Say something more about that. What about that x?
I just be knowing things like the
What about it? Where's the x?
It's exponent.
No, the x is an
Yes, sir.
exponent.
Light work.
Right away, if that variable's an exponent, it is an exponential. Literally, guys, like think about that. The variable's an exponent, so it's exponential.
Yes.
So you need to think about that. Vicari had a strategy that works really well that I'm going to talk about later, but I do want to remind you of this. Guys, if you are stuck and you have an equation and you got to make a table or you got to make a graph, what is a table? What is a graph showing?
Oh, I'm done.
There it is.
If it's a curve or not, like from like the points on the table.
But what are those points?
X
What do I call this?
X,
and
Y.
Hold up. Y'all missing another important detail, and I need us to recognize this. When you think
Oh,
x,
inputs, outputs.
thank you. When we say x, we need to think about input and output. Because notice, I started this group off like this. Hopefully you know how an exponential function works and how to get those different pieces and create a table and create a graph. However, if you're stuck, make 0 your input. Anyone remember what 2/3 to the 0 is?
Oh, 0. Oh, 1.
Oh, 1.
Anything to the 0 power. Remember, we looked at this a few
Zero.
times. It's, sorry, I just said this.
Okay, no problem. I'll say like times 0.
What is 6 times 1?
6.
6 times 6. Yes.
G of 1.
4.
So, you can type this into the calculator, but I always do this. What's 6 divided by 3?
Oh, 3.
2. What's 2 times 2?
4.
I'm tripping.
So G of 2. Now, I've got to square before I do anything else,
Yes.
right? Again, type that into the calculator if you need to, but 2/3 times 2/3 is 4/9. And see, this is where it gets a little tricky and why I'd probably use a calculator. But 6 and 9 both have a factor of 3. What's 2 times 4?
8.
And then 8 divided by 3.
Yes.
If you get stuck though, how do you create a table? How do you create a graph? You substitute your inputs in and get your outputs out. Guys, it will help you significantly if you know the starting point, you know the rate of change, but we should never have to look at an equation and go, I got no idea. No, inputs in, outputs out. It's harder, it's more work, but it always works. That's a function. Inputs in, outputs out. What I want y'all to do is I want you to take about 2 more minutes.
Yeah.
We got to finish this up because this is your review so that you can do better on Monday when I give you 30 more minutes. This is to help you get better prepared for the midterm next week. Let's go. Whoa.
Yeah, okay.
Yeah. There's a lot of really good stuff going over here, but there's also a beautiful error that I want to acknowledge and learn from. So first things first, I need us to understand, like we did this earlier, an input of 0 got us an output of 6. But I want you to look at this equation. Why should it make sense that an input of 0 gave us an output of 6?
Because you're 60 for white.
Right, remember guys, A times B to the X. We got to remember what A and B are. A is my y-intercept. And every y-intercept that's ever existed,
The X is 0.
the x is 0.
Yes.
That's my y-intercept right there. And then, so what do I call this b again? That's called a...
Slope.
Ooh, back up, back up, back up. We gotta remember, hold on. Slope is only for what type of function? Linear.
Oh, yes.
Slope is only for linear because what is slope actually?
Intercept.
That's how we calculate it, but what is
Change it,
slope?
why?
Change it, why am I
Change it, why?
That's
Change
how
it.
we calculate it.
MX plus B.
That's an equation that uses slope.
M,
So,
X.
my turn.
Ooh, child, stop.
What is it?
Constant
Constant
additive.
What?
Additive rate of change.
Guys,
Was I in the camera?
hey guys, remember, this is not for this problem, but we gotta understand the differences here to actually understand these two functions. The slope is your constant additive rate of change. Are we constantly adding here?
We're multiplying.
We're multiplying, so this is not what we're talking about. We're not talking about slope. We're talking about a constant what? Remember, we multiply with factors. And then multiplicative rate of change, but it's also called a constant
Because
factor.
it's multiplying, right?
So we're multiplying by 2/3 to go this way. That's how we get each of those numbers.
Gotcha, yeah.
Makari, you good with all that?
Yes.
Chris, you good? Kennedy, what do you have a question about then? I can't help you if you say everything. I need to know specifically where I lost
Bobby
you.
Hutchell.
Say again?
Bobby Hutchell.
But where?
Bobby Hutchell.
I can't, if you can come up with a more specific question, then I can help you. Okay. Try to figure it out later then. But constant factor, constantly multiplying by 2/3. Now, I do want to caution, right here, why does it say times 3 halves? Why are we throwing markers if we're juniors in high school? Why does it say times 3 halves if we just said our constant factor is 2/3?
I mean, I remember you doing that when you were doing the exponentials, so I
You
did
said
it
what?
that way as well.
Yeah,
I don't know how to
why,
explain it,
but
I-
why is it times 3 halves when we just said our constant factor is
Well, I mean,
2/3?
like,
I don't know.
that was for the positive, but like when you're doing
Because
negative,
this-
switch it.
Never mind. It won't go make
It's
sense.
opposite. When you-
Cause I always say one at the top,
It's like
and
opposite when
the
you're doing
way even.
negative.
Hey, listen, I got 3 or 4 people talking all at once. I need us to clearly understand this. Say again, Juwan.
We're going back and forth. They're doing before.
That's what I'm saying.
And
So
Opposite.
this is from going to the right.
Yes.
That's you always read from left to right. But if I'm going backwards,
It's going the opposite.
I need the reciprocal,
Yeah.
that 3 halves,
That's right.
right? Notice if I take 9 and I multiply it by 2/3, any guesses what I get?
6.
But to go backwards, I had to multiply by 3 halves. I would caution you against writing this though there,
Okay, yeah.
because that's going to be confusing.
Okay.
Okay, once you get your values, just graph those points, right? It is way easier to get a table and then graph the points. The last thing I want to caution you on is this. Have you ever seen me draw an exponential curve that curves back up like this?
No, it goes straight.
It goes not straight, but it gets, like, I want you to think about this. If I keep multiplying by 2/3 and multiplying by 2/3 and multiplying by 2/3, what's that going to get close to?
2/3.
Zero.
It's going to get close to 0. Because I'm constantly making this number smaller. But I'm still doing a positive times a positive, so it's never going to get negative, but it's going to continue to get lower and lower and lower and approach that x-axis. Don't curve it back up, because if you curve it back up, you're saying it's getting bigger.
Okay.
It's not getting bigger, it's getting closer and closer to 0.
Yeah, y'all.
Like a concave.
This is actually concave up, but that would have been concave up as well.
Yeah, that was my dad.
So,
And he didn't spell exponential. right?
He showed
that's the exponential, huh?
He put exponential.
Oh, I gotta put the L, my bad.
Guys,
That's what I'm
priorities, like, do I know what he means?
Exactly.
Okay. All right, what are your questions before we start working with some solving equations today?
For me, nothing.
Okay, so,
Okay, Sammy.
you got to go. All right, agenda. We actually finished up Is a Tesla Worth It yesterday. Yep, we did. And long-term, financially, a Tesla's not worth it, but if you care about the environment, a Tesla is worth it long-term is what we found. We're going to get into some solving of inequalities today. I'll explain what that is, but it's going to help us begin prepare for solving quadratics. Do not forget, I need y'all to remember this because the majority of us did way better today. But the reason we're here is not just to learn mathematics. It's to develop also those skills that employers want to see. They want to see that you have initiative, that you're complex problem solving, that you have teamwork, that you're collaborating. Like, those are the things we're working on. Leadership. There's going to be times, Dwan, hood off please. There's going to be times when you have to work with people you don't necessarily want to. So like, I need to tell you all this, buck up at times, because we got to learn how to work with people, even if they're not our favorites. It's an important skill, and to make it work. But y'all did better for sure of staying on task and working. Now, here's the context that we're looking at. Elvira, the cafeteria manager, needs to be careful with her spending. She manages the cafeteria budget so that they can serve the best food at the lowest cost. To do this, Elvira keeps good records and analyzes her budget. Now, let me find the problem that we're starting today with. Here we go. So, do they still do cartons of milk in the lunchroom?
Yeah.
Yeah, okay.
Yeah.
Sure. So in this context, right, Elvira has cartons of milk. The supplier is going to charge her 35 cents. 35 cents per carton. Okay, so 35 cents per carton. And there is a $75 delivery fee. So if you buy one carton, how much are you paying for your delivery fee?
$75.
Okay, well, just for the delivery fee.
Oh, delivery. Okay.
$75. If you buy 1,000 cartons, how much are you being charged?
75.
$75 still for that delivery fee.
Oh,
Okay, so my charge to you is if these statements are true, right? What is the maximum number of cartons Elvira can buy with $500? Okay, so what is the maximum number of cartons Elvira can buy with $500? So let's go to our vertical surfaces. Let's actively
You said
collaborate.
cartons of milk, right?
Justify your answers.
Okay, now,
If you're lost on an equation, what can you always make?
I'll tell you,
You can always make a table. You can always make a graph as well. And so if we're thinking about this, we do need to think through what our variables are. What are the two variables in play in this problem?
0.35.
That's not a variable, it's a number. Say again.
C.
C, what is C standing for? Okay, so we can use C. We don't have to, but I'd like C, because that's the number of cartons we've bought, right? What's the other variable? The money, right? Now back up, right? I heard someone say the delivery fee, but that delivery fee is not a variable. That's $75, right? So we got our cartons, we got our money, and which one's independent? Does the cartons depend on the money, or does the amount of money spent depend on the cartons?
The second one you just
The second one. So cartons are independent, money is dependent. And if we buy 0 cartons, how much money are we still going to technically buy?
75.
Hey, notice that's kind of like a y-intercept, isn't it?
Yeah.
Not just kind of. That's the y-intercept. If we buy 1 carton, how much are we spending?
75, 35.
2 cartons.
75, 80.
Calculators are a great friend, guys. So please note, by quickly making this table, and like I'll say this, I don't need to make this table because I recognize this pattern without making it, but if you don't recognize it, that's okay. Use your mathematical representations. What is happening here? 0.35 plus 0.35. Constant additive. Now, one thing I do want to point out with it, and I don't want to erase this, could I have gone by hundreds?
I get it.
No.
you could have.
If I buy 100 cartons, how much would we be spending on those 100 cartons?
Wait, $35?
Right? 35 cents per carton
Oh, yeah.
times 100 cartons. is 35. So that'd be 1/10. If I jump to 200 cartons, what's going to happen?
Well, I thought I had 75. One, two,
One.
135.
Isn't that, remember, another 100 cartons would be another $35, right? Jump to 300, another $35. Now, I gotta ask, and I know someone's probably going like, Mr. Kenny, you're adding more than it has to. No, I want us to understand this linear function. Is this table telling the same story as this table?
Yeah.
How so?
I don't even know.
It's just going up.
Going up by 35 each one.
But that's going up by $35. This is going up by 35 cents. By the way, you're hitting the TV, Addison. Keeps flickering like crazy.
We just multiply 100 by 35 cents.
Yeah, but let's also look at this. I want y'all to see this. What's happening to my number of cartons?
They multiply. Oh, man.
Because remember, when we talk about our slope, isn't that the rise divided by the run, the change in y divided by the change in x?
Yes.
So if we check this slope again, don't I get right back to 0.35?
Yep.
So can you go by something other than ones?
Yeah.
100%. I just want you to see that. It's still telling the same story, we're just going by something other than ones. But right here, this is what we really need to notice. What's happening here?
They
Addition.
Got
Actually,
zero,
it's for the
got
most
zero, you got
two-step
track
way.
rate 0.
But like, how do we get 0.35c plus 75?
You just put in calculator.
Equation's been made.
But
the amount.
how did we make 0.35c plus 75?
The
What is
amount
it?
of cart cost plus the delivery fee.
The delivery fee should equal out to 5.
It should, but I feel like there's something mathematically that I'm still looking for to help us make sense for all of us still struggling. Why is it 0.35c?
I don't know.
Oh, because
Because it's the price of the cart.
See that part?
But why is it Wait, is it something with times?
Yeah.
Why are we multiplying here?
It's
If
the
it's
amount of
35 cents out
cartons.
of the corner.
But why is it multiplying?
because
Because
the
the amount of
variable
cartons.
is changing.
Because the times C rate, times C.
Because of what
F
time?
times
It
B.
can change.
Cause all the
It
yeah,
not.
Oh, I know
all the,
this. Hold on.
all the carts
Why-
cost the same. Cost the
Y
same amount.
equals M times X plus
You
B.
multiply.
It is something with-
35.
F Y equals M times X plus B.
Because we're constantly adding.
Say that again, Dwan.
We're constantly adding.
That's how many times we talked about.
I just said.
But I didn't hear you, my bad. But like guys, we need to recognize if it is constantly, repeatedly adding, what are we gonna do?
Multiply.
Multiply. Guys, I'm trying to demystify this for you. I'm not trying to make it more complicated. I'm trying to get you to see if we are repeatedly adding by that, there's going to be multiplication. That's the same thing that I've said since like week 3 of this class, which is when we transition from statistics to linear, exponential, quadratic. If it is constant, repeated addition, we're going to multiply at some level. So why is it plus 75 and only 75 one time?
Cause then you gonna go and pay that one time.
You're only getting charged that one time, right? That's also my y-intercept. Now, I'm actually going to push back a little bit on what we did here, because y'all did a very good job. However, isn't 500 just the maximum?
Yes.
Yeah.
So could she buy less?
Yes.
Can she actually even buy 1,214.29 cartons?
Yeah.
Yes.
Really?
No, she can't.
Have you ever bought a quarter of a carton?
No.
So what's the most she could actually buy?
500.
1,214.
The most she could buy is 1,214. But I want to point out this out to you. It's going to help you in the next problem, and it's going to help you in the real world. Hey guys, in the real world, most problems are not actually equations. Most problems are inequalities.
Yes.
Notice, she can spend $500 or less. However, the way we solve it, guess what? It's exactly the same. I want y'all to notice, what are we doing? I love that this group did a couple of details here. I'm going to correct a few things. But notice, they did 75 minus 75, because what is that?
75 minus 0.
It's 0, right? What's that called, the subtraction in respect to that addition?
The zeros of equal.
There's an I word. Say it again. We got to remember that's inverses. When we subtract, it's creating that 0. Okay, so whatever you do to one side, we got to do to the other. That's called a property of
Equalities.
equalities. There we go. Now, do note, this would actually be called, this would not be called a property of equality right here. Do you know what it'd be called?
Property of inequality.
Yeah, right? As soon as we make it an inequality, it's a property of inequalities. Now, there is an error, actually there's two errors here that we need to learn from.
From the division thing.
It is something with the division thing.
They added the variable in it.
So first off, are we supposed to be dividing by C?
No.
No.
No, we
We're
want
trying
to
to
just,
get
we're trying to get C on its own.
Yeah. You
But also, hey guys, what's 0.35 divided by 0.35?
1.
That's 1, not 0. And we need it to be a 1 because, hey, if I do 0 times C, what would I get?
0.
But that doesn't leave me with C, does it?
No.
I need to be left with a 1. So when I divide by 0.35, notice there is no C associated or being divided with it because I'm going to be left with 1C is less than or equal to 1,214 cartons, right?
But we ain't gotta add that one to it though.
No, you don't.
It's-
Good.
We-
I just
we can
wanted
put
to
like an
be
X
clear
equal.
that we're creating that one.
Can we put like an X equals?
Sure.
Okay, good.
All right. What are your questions about creating and solving that inequality before we practice a little bit more?
No, for real.
Okay, so y'all ready for a little bit spicier one?
Yeah. Go ahead.
It's not really that much spicier. All right, here's what's happening this time in Elvira's cafeteria. This time around, students love to put ranch dressing on everything. Is that fair? Is that still a true statement?
Not at all. That's biased.
Okay, what type of sauce y'all like to put on your stuff?
I like barbecue sauce.
Ranch? Hot sauce?
I like barbecue.
You like barbecue sauce? I'll go with barbecue sauce. Alright, so students love barbecue sauce. We got some barbecue sauce on here. So students eat 2.25 gallons of barbecue sauce per day. Alright, they eat 2.25 gallons per day. And she has, it's not like they're drinking it straight.
You using it as
But
dip sauce.
you put it on your fries,
Yeah, I'm saying
you put it on your
chicken,
hot dogs, on your
chicken.
hamburgers, on your chicken.
I'm trying to tell you.
Alright, hey listen, if you want to make it honey mustard, you make it honey mustard. If Addison wants ranch, she makes it ranch. I'm going with barbecue sauce.
Come on, ranch.
You put barbecue on your hot dog.
Actually, no, I don't put it on hot dogs. You're right. I don't know, I'm just going offense.
And you put on your burgers too?
Oh, I love barbecue sauce on my burgers.
Yeah.
I ain't gonna lie to you.
Yeah. Huh? Yeah. Barbecue sauce on the burgers is truth. I'm telling you right here and right now. If you were to go to Texas, they would 100% agree. I'm sorry if you've never experienced it. It's great. Anyways, so she has 130 gallons.
Mark about to go dry.
You're about to go dry. Has 130 gallons, and she needs to reorder
We'll see.
with at least 20 gallons left. Hey, by the way, why do you think she needs to reorder when there's at least 20 gallons left?
Because she wants to give you no other gallons of it.
Well, that's part of it, but like I need you all to think about this like from a business perspective. Like if you are actually in a business, why would you need to reorder before you run out?
Because
if you run out, how you gonna be out?
Right. If you wait till you're out of that stuff, then while you're waiting on that next delivery to come in, you're not going to be able to serve people, right? So like, these are things to consider. So she knows students eat 2.25 gallons of barbecue sauce per day. That's probably an average. That's again why statistics is important. She has 130 gallons. She needs to reorder with at least 20 gallons left. We need to figure out when she needs to order by. Let's go.
Win.
All right, no,
Come on, buddy. It doesn't matter.
I can get some water.
You're gonna run like the wind bullseye. And how many times is she spending the 625?
How many pieces she got?
So she's repeatedly what with that 625?
Add
Repeatedly adding. I hear talking instead of learning. And then we want to be upset about not understanding. So plus 6.25, that's being repeatedly added, right? So times P. Guys, wherever there is repeated addition, what are you going to have? Multiplication. And then what's the relationship? We want to know when this is what?
Equal.
Better.
We want to know, we want this option to be,
Greater than. I mean, less than.
we want it to be less than. We want to know when is option 2 better. It's better when it is less than or cheaper. Guys, the emphasis for me on this, and I need y'all to hear me on this.
Yes.
If there is repeated addition, there's multiplication there. We want to make this complicated when if the idea is, hey, I'm repeatedly adding this cost, I'm repeatedly taking this thing away, that's multiplication. That's the idea of a linear function. Here, repeatedly adding 625, it has 4420 one time. Come on now, y'all can do this.